Hey everybody, it's Mr. Carr again. Today we're going to be looking at 4-3 day 3. We're going to get into what's called the unit circle, and we kind of played around with this idea a little bit, but now it's a very specific thing we're going to describe here. So let's start with what is a unit circle. A unit circle is going to be this circle we can draw on this grid that has a radius of 1. What that circle helps us with is determining all of our different trigonometric functions. Okay, so when any point that's on the unit circle as whatever that x comma y is, that coordinate point, that is going to tell us either sine, like any of our trigonometric functions. So what I mean by that is, for example, usually like say like I'm out here, and that point, let's call it, I don't know, let's call it, I don't, what are, okay, we'll just call it xy now. Sorry. And then so this is going to be my theta. Okay. So that's my theta there. The idea is that the sine of theta in this case is just equal to the y value. So whatever y value this is, that's going to be the result of the sine of that theta. Okay. Cosine of the theta is x, and then tangent of that theta is y divided by x. So another way of thinking about tangent, it's always sine divided by cosine. Okay. So that helps remember where that is. So we just take the x and y values and we divide them out. And then cosecant, secant, and cotangent is just reciprocals of those. Okay. So the idea again is that any point that's on this unit circle is going to represent the cosine and the sine of that theta. This is a 16-point unit circle. These are the typical ones we're going to use. It was made using our special right triangles. So technically you don't have to remember this if you just model it with a 30, 60, 90, 45, 45, 90 triangles, and plus our quadrantal angles as well. Okay. But the idea here is if I were to draw it for myself, here's what I always like to focus on. I start with doing my coordinate grid. So with a radius of 1, we get 1, 0, 0, 1, negative 1, 0, and then 0, negative 1. Degrees wise, it's 90, 180, 270, okay, and then back to 360. Then I can also do the radians. Remember, it's 2 pi to go all the way around for one full circle. So I would split it up. Here's pi. I divide that by 2. It's pi over 2. And then in between pi and 2 pi is 3 pi over 2. So I counted out. It's basically 1 pi over 2, 2 pi over 2, 3 pi over 2. Okay. Then personally, I will go through and start doing the next section, which is 45s. And it's also pi over 4. So when I do that, it's going to count by pi's over 4. So this is pi over 4. This is 2 pi over 4, which is the same as pi over 2. 3 pi over 4. Then 4 pi over 4 is pi. 5, 6 pi over 4, 7 pi over 4, 8 pi over 4 gets me back to 2 pi. 30 degrees is the same as pi over 6. Same thing as 60 is the same as pi over 3. But again, if I'm breaking up as like in terms of 1/6, so this is pi over 6 here. So I just start counting by pi over 6s. So 30 degrees, another 30 degrees is 60. So I would do this as 2 pi over 6, which is the same as pi over 3. I do 3 pi over 6. I add another one. That's going to get me back to my pi over 6 here. So again, that's 3 pi over 6. I'm counting by sixths now. Over here is 4 pi over 6, which reduces to 2/3. 5 pi over 6, and then 6 pi over 6 puts me at pi. So what I'm doing is I'm doing sixths. I'm counting by that. And then 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, and then 11 pi over 6, and then back to technically 12 pi over 6. So how this unit circle can help us is using our coordinate points. Okay. Again, since these are all set up as sine comma cosine for all my coordinate pairs, we can just identify very quickly what is the sign of sine, cosine, tangent, because tangent is dividing them out, and then our reciprocals as well. So let's look at an example of that. Find the exact value of sine 7 pi over 6. If undefined, write undefined. So the only undefined ones are going to be anything that's reciprocal or division. So sine, cosine will always be defined. So if I look at this one, 7 pi over 6, that position is right here. Okay. So normally when we did this before, we would draw it as a triangle. Okay. Make our reference angle right here. And then we had to figure out the trig from that. But now I could just go right to here. Since it goes cosine sine, that's what I said earlier, right? I'm sorry, I mixed that up. That is cosine sine, not sine cosine. My bad. Cosine and then sine, right? cosine, and then sine. Sorry about that. Okay, so since this is, I want to find sine, it is just the y value here, -1/2. So I am able to just go sine of 7 pi over 6 is equal to -1/2. Okay, pi over 3, find the cosine of that. Cosine of pi over 3, so pi over 3, here's my reference right here. Cosine is the x value here. So the cosine of pi over 3 is equal to 1/2. That's it. Okay, tangent takes a little bit more. So remember, tangent is sine divided by cosine. So that's going to be the same as taking y divided by x here. So 4 pi over 3 is going to put me right here. Okay, and that's my xy. So I can do that. My tangent of 4 pi over 3 will be equal to a negative √3/2 divided by -1/2. Okay, so now we just need to simplify it. Now from here, I'm going to recognize they're both positive, so I don't have to deal with that anymore. This is going to be the same as taking √3/2 multiplied by 2/1. I'm going to, instead of dividing by 1/2, I'm going to multiply by its reciprocal. So when I simplify that, I'm going to get the tangent of 4 pi over 3 is equal to square root of 3. And that's it. Okay. So one of the things to recognize about this is that with our trigonomic functions, they are periodic. What that means, what we're trying to explain here is that because of that circular nature of this, we're going to repeat these values over and over and over again if I keep going around more times in the circle. So example, if I go past 2 pi, and if like, so I go past 2 pi, so this will be something like right here would be, it'd be 5 pi over 2. Okay, so that's me counting up by more halves is the idea. So 5 pi over 2 is in the same position as pi over 2. Okay, and the reason why is because of the period. It's repeating itself. So the thing to remember is sine and cosine have a period of 360 or 2 pi radians. Okay, so what that means is, again, anything that's more than 360 will just repeat itself there. Sorry about that. So then when we look at tangent, tangent is going to repeat its values every 180 degrees or pi. Part of the reason for that is because we have y divided by x. When we get to our quadrantal angles like this, if I take y divided by x here, that's undefined. Okay, so we're going to have like repeated values for tangent every 180. Because again, and also the idea is that since all of them are positive here and tangent's positive down here, like we're going to kind of get this half circle of repeat of these values. And then it repeats those same values going the other direction. Okay, so the period of a tangent is only 180 or pi radians. Sine and cosine are 360 and 2 pi. Our reciprocal functions are also going to match up the same as the other ones as well. So how does that help us? Let's say we want to find the cosine of 9 pi over 4. 9 pi over 4, we got to first figure out where is this on the unit circle because it's not actually there. Now again, 9 pi over 4, the reason why it's not on here is because 9 pi over 4 is greater than 2 pi. Okay, we are going to complete one full circle and then come out into space somewhere. So let's find that spot. So what we can do is we can take 9 pi over 4 minus 2 pi. So instead of writing it as 2 pi, though, I'm gonna write it as 8 pi over 4. Okay, remember this is 2 pi. So 9 pi over 4 minus 8 pi over 4 is going to give me just pi over 4. My reference in this case is pi over 4. So again, the 9 pi over 4 is in the same exact position as pi over 4. Since I want cosine, cosine is going to be the x value here. So the cosine of 9 pi over 4 is equal to √2/2. And that's it. That's all we have to do is find that corresponding position. So it's just like with our coterminal angles. Okay. Our 9 pi over 4 is going to be coterminal with pi over 4 because it's on the same position on this unit circle. Okay. Find the exact value of sine of -300 degrees. So remember, -300 is going to go in this direction here. So if I think about it that way, I can kind of find the coterminal by taking -300 and adding 360 to it. So that's going to give me a positive 60. So what that means is -300 is going to go here. It's that same position. Okay. So if I'm going that in that spot, this is going to be my reference spot here. I want to find the sine of that. And the sine, oops, sine is going to be the y value here. So the sine of negative 300 is equal to the square root of 3 over 2. Okay. And we got one more we'll do here. The tangent of 29 pi over 6. So again, this is another one where 29 pi over 6 is larger than my 2 pi here. So I'm going to do this 29 pi over 6 minus 2 pi. But I want to do this in terms of sixths. So that's going to be the same as 29 pi over 6 minus, that will be, was it 12 pi over 6. Sorry, had to turn, I'm turning 2 over 1 into 12 over 6. So if I subtract those out, I get 17 pi over 6. Now that is actually still larger than 2 pi. So I'm going to do more than one complete circle. So I'm going to do 2 complete circles and then some. So I'm just going to take 17 pi over 6 and subtract another 12 pi over 6. And that gets me 5 pi over 6. So now I can find that my unit circle is right in this position here. Okay, so that means the tangent of 29 pi over 6 is going to equal to the y divided by the x. Okay, so 1/2 divided by negative root 3 over 2. Okay, so in this case, that is going to be the same as 1/2 multiplied by a negative 2 over root 3. You can cancel those out. We're going to have negative there overall. So the tangent of 29 pi over 6 equals a negative 1 over the square root of 3, which when I rationalize that will come out to a negative root 3 over 3. Okay, and that's it. The unit circle is very handy for a shortcut on all these. You could still model everything with our special right triangles. Like in this case, I would have done, once I get to my position of where is 29 pi over 6 on the unit circle there, it goes around twice and then ends up at 5 pi over 6. Then I would model that here. If that's 5 pi over 6, I would actually create 30 degrees here. So I could do that as 1, 2, and root 3. Cosine of that is the adjacent side, root 3, divided by my hypotenuse, 2. Or, sorry, 50, yeah, 5 pi over 6. So root 3 over 2. 1, 2. Hold on one second here. Sorry about that. I got mixed up with my cosines there. Yeah, so if I were to model this as a 30, 60, 90 right triangle, that'd be 30, that'd be 1, 2, and root 3 there. So it's opposite 1 divided by adjacent root 3. So 1 over root 3, which is what I had here. And it's a negative because it's in the second quadrant. So it's the same exact stuff. It's just the unit circle offers us a bit of a shortcut. So in understanding how that periodic way works on that function. Okay, that's it for today. All right, take care, everybody.